Alright, our next lesson is going to discuss how to solve equations, which you've done a lot of between Algebra 1 and Geometry, but some basic rules about equation solving. I think it's a great idea if you separate your equation through the equal sign, and then you see the left side and right side clearly. If you're moving across the equation, that means you have to do opposite operations. So like here, if you're going to move the 7 to the right, you're going to have to subtract 7 from both sides to balance it out. And then as everything with Algebra 2, I want to see all your work. We'll get fancy with skipping steps later. Now's not the time. Alright, so here we're going to divide both sides by 4. And we get x equals 5. And that's how I want to see your work as well. So remember, coefficients. If they are fractions, that's actually a multiplication and a division problem all in one. So the quickest way to get rid of a fraction coefficient is to multiply both sides by the reciprocal of that fraction. So the reciprocal of 5/2 would be 2 over 5. So when you multiply both sides of your equation by 2 over 5, over here on the left, these cancel, and you just get x. And then 20 times 2/5, you could literally type that on your calculator. So 20 times 2 divided by 5. And that comes out to 8, I believe. Alright, moving along. If you have variables on both sides, you got to make a couple of movements. Now, because we are in Algebra 2, I don't mind if you do both of these steps on the same line, but I do want to see your work. So you have to decide what side of the equation you want to bring your variables to and which side you want to bring the constants to, and they have to be on the opposite side. So for a lot of kids, they like to keep the variable positive, so they're going to move the 3a over to the right by subtracting it. So if you're moving variables to the right, that means constants have to move to the left. So this -8, if we add it over here to the left, then everybody's where they need to be. So we end up with, let's see, that's 21 equals 6a. And then we're going to divide both sides by 6. Algebra 2 teachers love reduced improper fraction answers. So on your calculator, if you're not sure about how to reduce this fraction, 21 divided by 6, and then hit math, enter, enter. And that'll change you to a reduced improper fraction. But if you're doing this in your brain, both of these can be divided by a 3, so that would be a 7 over 2. The decimal answer is also acceptable here because the directions didn't say how to leave your answer. The only thing I really don't like is rounding and truncating decimals when it's not necessary, because then you really just are giving me the wrong answer. So here on this next question, we have some distribution, which is going to give us a -12x plus 4 on the left side. And then this is a -10 being distributed into that parenthesis set. So that's what? -10x. Careful with the double negative here. This is a plus 40. And then this -14x term has not moved, so just leave it there. Now on each side of the equation, I want you to clean up what you can before you start moving across the equation. So I notice that right here, -10x and a -14x, if these combine, you get a -24x plus 40. Is still equal to -12x plus 4. And then now we're going to move variables to one side. So I'm going to add the 24x to the left, which means I'm going to move the constant 4 to the right by subtracting it. So we end up with 12x equals 36. And then divide by 12, and you get x equals 3. Awesome. What I like about equation solving is that it's a huge skill for algebra, so you've done a ton of it. What I don't like about it is that every single moment you have is an opportunity for a small mistake. So you have to be really, really careful when you're going through your work that you're not being sloppy and you're writing down everything you can, because that's how we prevent mistakes. Now, if we were doing this during class, I would ask you guys how many of you like fractions, and pretty much nobody would raise their hand unless you're being silly, because even I don't like fractions. So what if I told you that we could take an equation with fractions and multiply by what's called the least common multiple, not so much the least CD, but LCM, and in doing so, we create a new equation that's still equivalent to the original one, but it no longer has any fractions. So what you do is you take a look at your denominators, and you're going to come up with what's called a least common multiple, or even a common multiple for those numbers. So the multiples of 6 are, 6, 12, 18, 24, and so on and so on. The multiples of 12 are 12, 24, 36, and so on and so on. So the first number that they have in common is the 12. It's the same idea as multiplying by or getting common denominators. So what you're going to do is you're going to throw that LCM out in front of your problem, and you're going to distribute it to every single term. So 12 times x is obviously a 12x. 12 times 5 over 6, if you are worried about the fraction work, go ahead and just type that on your calculator, but let me show you a little shortcut. When you multiply by a fraction, remember a fraction is a multiplication and a division, and you can do these in whatever order you want. So like for most small children, before they get calculators, they choose to divide first because it gives you a smaller number. So 12 being divided by 6 is really a 2. So this problem really says 2 times 5, which is how we're going to get the 10. You also get a 10 if you just type 12 times 5 over 6. And then 12 times 2 over 12, well, same idea. 12 times 2 over 12, the 12s are going to cancel, and you get 2. Look at that, a beautiful equation, not a fraction in sight. So we're going to add 10 to both sides. We get 12x equals 12, and not so terrifying answer of x equals 1. So I really like that method, and we're going to require you guys to use that method even if you think you can come up with that answer a different way. You have to use this method at some point because we're going to use this method for something else later on in algebra, and we need to practice this on the easier questions. Alright, so this question, I'm looking at my denominators and I'm seeing a 4 and a 5 and a 2 and another 4. So as far as the 3 different numbers I see for denominators, I have to get rid of a 4 and a 5 and a 2. So you have to choose a number that's large enough to knock out each of those. So I'm thinking a 20 would be a good number. So when I distribute a 20 to each number, and again, you are welcome to just type this on the calculator. 20 times 3 over 4 is going to be a 15x. 20 times 3 over 5 is a minus 12. 20 times a 5 over 2 is a 50x. And then 20 times a 1 over 4 is a plus 5. So we have this beautiful couple-step equation here that I'm just going to solve pretty quickly here. I'm going to subtract 15x so I can move my variables to the right this time. And while I'm at it, let's move a constant to the left. So we have negative 17 equals 35x. And then our last step would be to divide both sides by 35. And we end up with this really disgusting fraction, but what's cool about Algebra 2? I like disgusting fractions. If they don't reduce, which this one does not, and you can try math enter on your calculator, I just want you to leave your answer like that. Now this next question already has a distribution problem and a set of fractions, so let's get rid of the parentheses by distributing the 3/4. A little refresher of 4th or 5th grade maybe. When you multiply fractions together, you can do a little cross-canceling, and that makes your math a little bit easier. And of course, I'm never going to take your calculator away from you, so you can just type 3/4 times 4/5 on your calculator. Either way, you get 3/5 x minus, same thing here, 3/4 times 2, or 2 over 1. The 2's and 4 would cross-cancel, and you get 3 over 2. Again, you can type that on your calculator and hit math enter if you're not so handy with the fractions here in August. Alright, LCM for a 5, a 2, and a 4. Well, that's the same as the last problem, so we're going to use a 20 again. Hit every single term by the 20. 20 times 3/5 is a 12x. 20 times 3/2 is minus 30. And 20 times 11/4 is 55. Go ahead and pause the video and decide how you're getting those numbers. If you know exactly how to type them in and you can still come up with these coefficients, great. If you are doing this in your brain and you're coming up with these coefficients, great. This is usually where kids struggle the most on that question, is knowing how to get the 12, the 30, and the 55. And it has to do with kids not typing it right. Alright, so we're going to add 30 to both sides. And we have 12x equals 85. So dividing both sides by 12, this fraction does not reduce. So I'm going to leave my answer as 85 over 12. Oops, I didn't mean to do that. I don't know. Can't move that out of the way. I don't know what's happening. Alright, try again. 85 over 12 is our answer. I promise. Alright, there we go. Leave it. Oh, proportions. I know it's been a while, but you still solve them the same way. We're going to learn later what we're truly doing when you solve a proportion, but you guys know this as cross-multiplying. And you can cross-multiply when you have it set up as a fraction equaling another fraction. You just have to be careful that you are distributing. So, for instance, 6 times x plus 2. You're going to have to multiply both the x and the plus 2 by the 6. Equals the other diagonal, which is 4 times x minus 3. So going through our distribution, which, yeah, you probably could have done that in your head, but it's August, we're tired. Alright, so we have 6x plus 12 equals 4x minus 12. And now we solve. Alrighty, I'm going to subtract 4x. If I brought the variables to the left, my constant's going to go to the right. So I'm going to subtract 12. Now be careful. Sometimes kids think those 12s cancel on the right side. They do not. We have 2x equals negative 24. So when I divide both sides by 2, I get x equals negative 12. Voila. 9 almost looks like a proportion. It's not quite a proportion yet. So what if we took this 4 and we moved it right away? That's what I would do. So you have negative 2x plus 10, all of that being divided by a negative 5, and it equals a 9. Now, one might argue, oh, what are you talking about, Abruzzo? That's not a fraction over here, it's a 9. Well, everything is a fraction if you think about it, because 9 is really 9 over 1, right? So if you were to multiply now, the negative 5 times the 9, that gives you negative 45 right there. So negative 2x plus 10 times 1, that doesn't do anything exciting. I'm just going to write that down. But apparently it equals negative 45. And now we solve. So I'm going to subtract both sides with a 10. So I have negative 2x equals negative 55. Watch your double negatives here. We have 2 negatives being divided, which means our answer is actually going to be a positive 55 over 2. Leave it as a lovely fraction. Alright. Next couple questions here are going to revisit the idea of going to a word problem and setting up the algebra and then solving, of course. So a real estate broker's base salary is $18,000. She earns a 4% commission on total sales. How much must she earn in order to earn $55,000? So for our verbal model, we want to figure out her total pay, right? That's our, well, we want a certain total pay. Now, how we calculate that total pay is based off of sales. So she gets a base salary, no matter what, but then she's going to make commission on her sales. So when you make commission, you take your commission rate and you multiply that by the sales. So I know a lot of this information. The total pay I want to be $55,000. The base salary I think we know is $18,000. The commission rate, now be careful here, it is 4%, but we don't write that in an equation. We have to convert that to a decimal by dividing it by 100. So we're going to get that as 0.04. The thing I don't know is how much she sold, so that's going to be a variable. I'm just going to call it X. Move that out of the way. There we go. Alright, let's solve. So I'm going to subtract both sides with 18,000. So what is that? 37,000 equals 0.04x. So now dividing both sides by 0.04, and this number should be pretty big because what we're solving for here is the amount of money that she sold in real estate. So for a whole year, how much money does she sell? And I think it's like 900 and some thousand, which makes sense because for a year, you know, she's selling a handful of properties. I think that's a logical number. And that's one of the skills we want to develop in Algebra 2. As you get your answers to story problems, if they don't make any sense, you got to think about that and maybe realize what mistake you made. So she needs to sell $925,000 of real estate in order to make her salary of $55,000. All right. Here we have a summer job that pays $5.60 an hour and then $8.40 for any overtime hours, which is anything over 40. So how much overtime do you have to work for your paycheck to come out to $287? So for my verbal model, I want to find or figure out my total pay. Or no, I know that, but I want a certain total pay. So then she's got her regular hours, and we're going to multiply that by what we call her regular pay. So she gets a certain pay for her regular hours. However, then she gets overtime hours. So her overtime hours times her overtime pay. And that's going to be her total paycheck. All right, total paycheck. I want $287. Regular hours is 40 times her regular pay of $5.60 plus, I don't know her overtime hours, but I do know her overtime pay is $8.40. So if you don't mind, I'm just going to call that 840x. Now this number, whatever this is, I'm going to calculate that real quick. We need to subtract that over. So this is 224, excuse me. So we're going to subtract 224. And then it's $63. So we have $63 that she has to make up in overtime pay. So dividing both sides by 840. I get, as long as I typed right, 7.5. So she needs to work 7.5 hours of overtime. Dream big, girl. Dream big. Or you, I guess. I don't know. Whoever you are. Alright. A new iPad was purchased in Algonquin for $464, but that includes tax. The tax rate is 8%. Find the price of the iPad before taxes. So, your total price is calculated by, usually we say it's like a subtotal, but I don't know what you want to call this, original price maybe? Because you're just buying one thing. But then you have to add into that all your tax. And the way tax is found is you take a tax rate and you multiply it by the price, the original price again. It's messy writing, sorry about that. So total price is $464.40. I actually don't know the original price, so I'm just going to call that X. And then the tax rate is 8%, so that's 0.08, and then times that X again. So using my equation solving skills, X plus 0.08X is 1.08X, which makes a lot of sense, because what I want you guys to start thinking about for these sales and tax problems, if you're paying more than 100% because you're increasing the price for something like tax, 1.08 means 108%, so that makes a lot of sense. All right, divide by 1.08. And I bet it comes out to something pretty. Let's see, 464.4 divided by 1.08, $430. And again, this is a good opportunity. You all shop, so you know how this works. If I said my original iPad price was $430, and then after taxes it was $464.40, that makes sense. All right, the next lesson is 1.4 part 2, where we isolate variables. So go ahead and watch that if you're in need of that one. That is a pretty tough lesson. This one should have felt pretty much like a review. I would really focus on those LCM questions with the fractions. Those are the ones that give kids the most trouble.